The smart home automation platform I use for energy load control is Home Assistant, powered by a $40 Raspberry Pi. The Raspberry Pi has both a Wi Fi and an Ethernet connection. Let's take a break from the discussion and do a demonstration of how to set up this smart home controller. What we're doing here is building a local device using the Raspberry Pi as the computer hardware. The home automation software Home Assistant will then be stored on the computer. The Home Assistant software is open source software which can be freely downloaded and even expanded upon. This means our home energy controller will not be reliant on a cloud service and will continue running on into the future. The version of Home Assistant I recommend using is Hassio. This is because Hassio is easier for non-coders to connect up with perhaps obscure third-party technical applications. So this is not a problem for basic devices such as the Google Mini or the Amazon Alexa or other mainstream devices like Nest and smart doorbells and smart speakers. But to set up a energy monitor and data logger, some rather obscure databasing and graphing software will become necessary to use. So we want to do that in the simplest way possible without much programming involved. So first I will start out by visiting Home Assistant's official documentation. There are many how-to guides for Home Assistant out there. Using the official guides will make sure that you get the proper technical support you need. Speaking of technical support, this is where open source software really becomes fun because the software allows for programmers to make contribution to the code. There's a large user community enthusiastic to help you get your energy controller set up. There's a chat program called Discord, which is primarily used by computer gamers to talk to each other, but it also has a following within the technical support community. It is similar to group messaging software Slack, but more like a chat room from the 1990s. Home Assistant has an active Discord community that provides support for beginners and programmers alike. So you won't be alone when attempting to install the open source home automation Home Assistant software onto your $40 Raspberry Pi for the very first time by joining this Discord online community. It's especially valuable for lacking computer skill. Personally, I find this to be the best way to learn about computers. If you have children at home, steering them towards a Raspberry Pi with a home automation build could provide a very solid introduction into computer programming. It's a platform that is technical, but also more friendly towards beginners than other kinds of computer electronics manufacturing that I can think of. As a reminder, use the Hassio installation method because of its add-on capability, which makes it more compatible with more devices without as much programming as compared to the other Home Assistant kind of installation called HASS, that's HASS, which is done either in Docker or within a virtual machine environment for the technophiles out there. So install Hassio instead of HASS. A few different download options are presented for the Hassio software. These are for different kinds of computers which can run Home Assistant. I recommend starting with a Raspberry Pi. That keeps things simple. The need for more robust computing options will be discussed a little later in the program, but a Raspberry Pi is sufficient to implement a modest smart home build. The next step will require many of us to take a step out of our comfort zone Essentially, the operating system and software need to be installed onto the Raspberry Pi hardware. This step is done using the Balena Etcher program. On Macs, it's called Etcher. To write the code onto a specifically Raspberry Pi friendly memory card. It's a standard data card. The software is then burned onto this memory card. So I got lucky. My laptop has a memory card slot that fits the same memory card as the Raspberry Pi. But already I'm faced with a technical challenge. I'm using a Chromebook, which is not a Windows PC or a Mac or even a real Linux computer, but I need to burn this software image onto the memory card. So my memory card fits into my Chromebook, but Chromebook doesn't have the Etcher software that I need to burn the image file. However, Chromebook has their own recovery tool which does the same thing as this Etcher program. This is a program that would help you create a backup boot disk to a computer. So loading an entire operating system onto a hard disk, your computer crashes, put it in, your computer boots right up because it's running off the hard disk. That's what these Etcher programs or recovery programs do. They allow you to write the image files of electronics operating systems onto a boot disk so the device will start up at power up. So that is what we are building. So I select a local image because I'm selecting the image file that I have locally downloaded onto my computer from the first step. You might think, well, why is it called an image file? Imagine a analog record player, and if you zoom in real closely with a magnifying glass, you can see the little bumps in the record that the needle detects, and that's what plays the music. An image file is the same thing. It's a bunch of ones and zeros that the computer processor is spinning up into your software and boot disk. So it is the image file of what the computer needs to see in order to turn on and use all of its parts. So it tells me to put in my SD memory card. It then says that my SD memory card will be erased to create a new recovery image. I select create now, and within a few seconds I'm done. The next step is to preload the customer Wi-Fi information onto the machine. This involves opening up the SD card and adding a file to it. So it turns out my SD card won't open, and I'm already wondering if I've done something wrong. When I click on it, it won't open. What I can say about flashing software onto hardware, which is what we're doing, is that the instructions must be performed exactly, otherwise it'll break and not work. I run into some more snags, and I go to the Discord group for advice, and the advice is often to follow the instructions. So consistency is nice. If getting off from the instructions results in a mistake, you probably need to get back on the right path. But I still couldn't figure out what my problem was until I realized that by downloading the Home Assistant software, whatever zip program it was using, whatever zip program I was using was removing the title from the zip file. And so I put the image extension back into the file before zipping it up and then reburning a new image onto my memory card. And finally I can open up my memory card, and that gets it working. And so if you walk down a couple of steps into your home automation software and it's not working, that's the right time to stop and go back until where things were working and try to do things exactly per the instructions. So I want to give the machine Wi-Fi access so that it can download any necessary software it needs to when it boots up without me having to plug it into, say, my own computer to tell it what to do. A client's Wi-Fi password could be pre-programmed into these machines so that the device would work right out of the box when it ships to site. So I have to create a text file containing my Wi-Fi password and put it in a very specific location on the SD card image file in a folder known as the boot folder. This will load the Wi-Fi password onto the software so that when it powers up, it will automatically update itself. Other configurations could be used to allow the use of Ethernet only. My efforts have worked because the Home Assistant software has created a website at the address of the Raspberry Pi on the local network using the Wi-Fi password access we just gave it. So the Raspberry Pi now has access and we can log into it and go through their Home Assistant registration process. Already it's recognizing the Google Minis and Chromecasts on my network. I also take the time to register my Z-Wave memory stick by telling the software the location of the memory stick. I actually don't know the answer to this. I don't know the answer to my Z-Wave memory stick USB drive location. But there are plenty of websites out there with the answer, so I simply use the information online. Because the Raspberry Pi is such a uniform hardware, there's many others who have encountered these obstacles beyond yourself when going through the basic process of setting this kind of system up. And by simply learning the answer from a quick internet research, I don't have to go through the process of actually logging into the kind of DOS command line interface to find what the answer to these technical questions are the hard way. It would now be an appropriate time to pat yourself on the back for building a smart home controller from scratch. Later we will add our smart devices to the controller to start managing the electric load. But let's do two more steps first, which will assist the controller's data logging and display capability. The point of this exercise was to show a very specific Hassio installation of Home Assistant. What Hassio gains the user from downloading Hassio instead of the other version called Hass is that Hassio has this add-on store which spares the user from learning much of the hard way on how to program different devices into the controller. Hassio recommends installing the Samba add-on as well as the SSH add-on. Without getting too far into details, this is to promote communication when connecting between the Raspberry Pi and another device. We're going to install the InfluxDB database add-on to store data from the energy monitor. So data needs to be stored in a database. We've added some software to this computer card, but we didn't add any database software, so we add that at this point. When I install the Influx database add-on, I can't initially use it. So I look in the config files, the configuration files, and I go ahead and disable the HTTPS option in order to get it to communicate with my computer over the computer network itself. Over the, not the network, over the device itself. It doesn't need secure communication to take data that's already being communicated to the Raspberry Pi and process it. So I'm not going to set up a security certificate for that. And so I disable the HTTPS option. After restarting the database and giving it a little bit more time, it starts to work on my Raspberry Pi user interface. There isn't any data in it yet, and I have to create a database called Home Assistant and a username called Home Assistant. I use my Home Assistant software password for this Home Assistant user. So for some case where InfluxDB is communicating with the Home Assistant software, I keep the username and password consistent so that there's no conflict. And now InfluxDB is installed. I do have to remember to go back and give this InfluxDB user full administrative privileges, because the next add-on we're going to install, Grafana, requires those administrative privileges in order to have Grafana communicate with InfluxDB. So the next step is to install Grafana. Grafana is a software that focuses on displaying metrics, so it's very useful for displaying energy metrics. I'll also disable the SSL communication in the configuration file and then start reading through the documentation. So the Grafana documentation suggests to create a new admin user, and I'll create the same user as my Home Assistant user and the same password as my Home Assistant password. The next thing I'll do is add a data source and select InfluxDB as the data source. So Grafana and InfluxDB, are cross-compatible. So, I'll enter in the information, but I still get an error. And so I need to go back into InfluxDB, give my InfluxDB Home Assistant user full admin permission in order to make queries into Grafana. So I go back and give it the permission, come back into Grafana, refresh it, retry it, and now the data source is working. So the Smart Home Hub is now ready for the energy controller peripherals, which we're about to get into, to be registered. So we'll come all back to this in a minute. For now, let's get back into